All right, everybody, my name is Rick, and we are continuing this side quest. We're going to try to run this sample code here to make a REST call. This is written entirely in Swift, and our goal is to use it to hit this API from Datamuse, which will tell us about word frequencies. We're going to pass it the long list of valid words that we have, which is around 14,000 words. And for every word, we're going to get its frequency number, its score, and we're going to analyze it, just break it down, see which one has the most frequent 5-letter word, a suitable Wordle word, and use that as take all the words that are most frequent, the top 5,000-6,000, and boom, we'll update our dictionary that way. Now, in the last episode, number 48, we tried to run this code, and I'm going to try to run it right now. Projects, Wordle, and if I do Swift run dg call rest, this is going to exit unceremoniously. It's going to say done, but there's all sorts of work it's supposed to be doing. And see it. We'll get to it. Its result. Yeah, so it returns done, and it's like, wait a minute, what about all this code here that's it's supposed to run this function, update IP. It's going to hit this endpoint. And it's going to get the IP address of my internet from this website. So it's supposed to get this JSON file, JSON output, but clearly it's doing nothing. And I think one of the things that so off screen, offline, I was working on debugging this. One thing that I noticed is that my scheme contained deg call rest, and I could pick between these. Doing so allows me, when I select this main app, I'm able to run it. If I do that, you'll see the same output that we saw here, which just says done, right into here. Now, I'm going to get right to the punchline. I have figured out what the problem is, or at least I figured out what I think the problem is. So we're going to analyze it, or I'll show you the steps that I did to analyze it. It's intriguing because this example from DU is part of a Mac iOS application, and it's already running inside of, it's an app running on a device, and it's got functionality that surrounds this call here. What I've done is I've taken that one function and I've set it up to run in main. But when I do that and I run it, it does nothing. And I put it into, I'm trying to remember now, what exactly was the step? But before I get to those steps, I wanted to try to run it in the debugger and show it on here on the screen. Yeah, so it's running it now, and hopefully I'm going to see something happen. Am I? Nope. Oh, wait a minute. Yeah. Okay, there it goes. So there's the program finishing. And what's interesting is when I run it in the debugger, like right here, I run it again, and this time in the debugger, we're going to step through the code to see what exactly is happening. So let's do that. Stepping through the code inside of Xcode. I'm at the breakpoint, so I'm right here at the start of this function. I'm going to just follow it along. I'm going to step into it. And I thought, holy mackerel, I am in the function. So I'm in the function. I'm just going to step into it some more. Oop, I think now it wants to go and register something here. What Xcode is trying really hard to display is the variables, the local variables. And here it finally got to it. It's got the URL, the post endpoint. It should actually, sort of surprised it's not displaying it. Okay, good. Yeah, so here's the display. Look at that, underscore guts. And now it's gonna create a URL object. So we'll go a step into that some more. It finally gets to here where it's going to create a dataTask. I remember this dataTask is something that we found in the help. Now it's not in this help when I clicked on it. Okay, maybe it was, but I can now look at this inside of the developer doc. When you read it, it turns out that this is a function that's going to make a REST call. It's going to try to retrieve data from calling the endpoint. But it uses a very particular language here. It says it's going to create a task. It's going to then send it to the completion handler when the load is complete. So this part here is really just setting up the call. I'm going to go continue. Step into. And it's getting ready to yeah, it's basically saying, okay, I have taken this data task, this block here from this curly brace to this curly brace is the completion handler. So what should happen is task.resume is going to say, go ahead task and run. That's what a task.resume is. You must start it by calling the resume method. So I'm going to go and do that. I'm going to say, I'm just going to go step over it, which will be the same thing as calling it. It gets to the end there. I'm going to step over that. Then it gets to here. It's finished. setting up the call, and now if I step over it one more time, it prints done. It exits. It never ever gets to the REST call. It never gets to the completion handler. And I think it was easy to, so what I did is I just searched on the Swift forums about, I don't know, like dataTask not working, dataTask stuck. Because I'm using it in main, I put in the keyword main, and I eventually found this post here. So watch this. If I go to this post, they're basically trying to help this person with their REST call not working inside of Swift. And this person here, Jeff Kelly, Sláinte Man, writes, "Are you sure the issue isn't that you're blocking the main thread while you call sleep? Try doing something like this." So you can see it's the exact same thing we're doing, the data task. But what it has is this, it uses these semaphores to guard the run of the program. I'm not here to teach people about semaphores. I'm hopeful that you might know its concept as a way to block and control access to program functions or variables. Essentially, when we get to this wait here, we're going to wait. And this signal is going to, when we get to the completion handler, tell it to stop waiting. So I took this program and copied it in here, dataTask semaphore, and it's a Swift program. So it's interesting. You could compile this, but I found that you can actually just run it directly by just saying Swift dataTask semaphore. So it's going to run this code. And watch what happens when you run it. If you notice, it gets into the goodbye world, it gets into the completion handler, and when it calls this signal, it then prints 3 period task state and then the raw value of here it says 3. I don't know what task state values are. Probably something important. But this was an important clue, and it made me think about why this program didn't work. I made a separate branch called Fixing REST Calls, and this is up in the GitHub already. So if you go to GitHub, you'll see it. When it loads, you'll notice that I have set up a semaphore also from this. And when I run this now, I'm going to disable this breakpoint. If I run this code, watch what happens. That's success. When I introduce the semaphores, all of a sudden this code begins to work. What it does is it prints the data from the REST call, and then it puts the data into a JSON object. Hereby looks like serializes this, puts it into a dictionary, and then we can just grab the IP address from the origin here, and we print out just the IP address here. Now there's all this mysterious stuff with SQLite file protection. I don't know what that is. But what we have now is working code. Now there's a semaphore here, but I'm guessing in the end this wasn't, it probably isn't necessary. And why do I say that? Let's see. I say that because from iOS app, this iOS app is constantly running, and it's got its own separate runtime, if you will. Here in main, I'm just a single thread running, and when I exit here, from here and go to here, if I'm not waiting for this to be called, then it doesn't ever get called. There are a few posts that are interesting. I'm going to post these into our description. Here they talk about blocking the main thread. There's this lengthy document on non-actor isolated async functions. That sounds fancy. I don't know what that means, and when I click through it, it was also over my head. But I then kept going to try to understand it some more, and I found this post. Why a wait on the main thread does not cause deadlocks? Now, again, I'm not going to introduce people to async and the wait. This gentleman says, go and read about concurrency. You go here to this link, and this is right from the Swift language documentation. And it talks about how to do asynchronous operations. Now, I think I mentioned that in my day job I work in Node, and in Node you're sort of forced to contend with asynchronous operations. That's what this is doing. This thing is a big, gigantic async operation, and here what I've done is I've not waited for it. I like to think I thought, if I go back to main, I thought that if I do an await, that it would just simply wait for my function. So here I am, I'm going to try this. So I'm in main now, back in the code that does not work. If I do await here, let's see what happens. Yeah, I got a build failed, and if I look, I'm in a function that does not support concurrency. But watch this. What function am I in? And in order to add concurrency, I need to have a function kind of set up like this. Nope. Oh, I missed it. Defining and calling an asynchronous function. I need to have a function that's kind of set up like this. Async. So I now try that. But the reality is, await, I'm in a function and I'm not in a function here. If I say update IP, it's a function and I declare it to be an async function. I think it's void, and I'm going to say, let me see if I got that right. I don't think this will work. Oh, right. I get this crazy message. Concurrency is only available in macOS 10.15 or newer. And I remember thinking, I'm on macOS 11. I'm on Big Sur. So it was a confusing offline session of just trying to understand this a little more. In the end, I've made peace with the strangeness of it all. This last post is very interesting because it goes on a while. Here it says that semaphore.wait is blocking. So here, if I let me go back to fixing REST calls. Oops, let me back out of these changes real quick. If I look at this fixing REST calls and I look at the semaphore.wait, it's clear that what this is giving us is really a way to pause main, which I believe allows this data task to run and reach its completion handler. When it does that, I tell the semaphore that, hey, I'm sending you a signal, and the semaphore drops, and it prints done. And so that's what's happening with this funky code. I think I'm gonna end here in that I learned a lot, and I just wanted to spray it out on the internet, spray it out here on my YouTube, and just have people absorb it, and more importantly, to have me absorb it. Because what's going to happen next is I'm going to now write a program that will basically call the endpoint that we want, which is the Datamuse endpoint. This endpoint allows us to do frequency analysis. If we use the letter F with the metadata flag, I can find out how frequent the word flower is. So if I do that, I'll open this in a new tab with a frequency of 14. .9, and we'll even use something like taser. Some spell corrections here. There is no MD value. That's fine. I'm going to keep it in our dictionary. But if I do something like audio, you can see it's got a frequency number of 8. And what we're going to do is we're going to take all of the words that are invalid words and just pass them in, like abode. This is the one for audio, but if I let's capture this. I'll just put it in another window. Do I have JQ on here? I do. So if I put in so that's audio. Now if I put in abode, you can see that it has a frequency of 2. And I'm going to guess that audio is more popular than the word abode. And what we'll do is we'll write a Swift program to put that in a dictionary, grab the F value, and we're going to put it in a CSV file. We'll sort it, and then from there we will generate our new somewhat curated dictionary courtesy of the Datamuse API. We're probably going to run into some things along the way, like I anticipate calling this 14,000 times, or at least starting to call it will probably not work. Let's try it with 100 words, and I'll have to obviously run it overnight and in batches, because there's 13,000 words that we're going to examine. And if every REST call takes, say, a second, that's going to be 247 minutes, which is going to be 4 hours. And so we're not going to do that over on YouTube, but we'll at least start it with a few, and I'll report offline what it looks like. So that's what I'm going to do, and you can too, because I'm going to now merge this code into main. There should be, I wonder, wow, I didn't have to, I thought it would make a merge request, but I guess I'll, yeah, I'm just going to say git push. Yeah, okay. So that's the new commit 586E924. You saw what we're going to do with this output up here, with this output here, and we're that's what we're going to do in the next program. We're going to go and take this Wordle words. We're going to do this loop here. We're going to load all the words, and then while we're in this loop, we're going to make a call to Datamuse. So you could see how we're going to build this up. I hope you join me for that. I'm going to be doing some of it offline just due to the nature of the number of words we're examining, but certainly the writing the program we'll try to do that online. Thanks for checking this out. It was an interesting voyage. When you look at the show description, you'll see these links to those Swift posts. Read those over and you'll see some of the details that I was wrestling with. I've not written the code yet with this big loop. I expect there to be potentially some issues that we may have to solve using kind of these workarounds like this. But now that we at least have a workaround, we can go forward. Thanks again for checking this out. I'll catch everybody later on.